Welcome to Ecolution, where we delve into the fascinating journey of energy production and its numerous hurdles. In this episode, we will scrutinize the most significant power station failures that have greatly influenced this evolution. From nuclear power plants that marked the dawn of a new energy epoch, to wind farms that brought unforeseen difficulties, these tales paint a colorful image of our relentless pursuit of power, the hindrances faced, and the wisdom acquired. So, accompany us as we embark on this enlightening journey, starting with the Satsop nuclear power plant, a story of abandoned dreams. The Satsop nuclear power plant project, set in motion in the 1970s, was an ambitious endeavor aiming to meet the increasing demands for electricity in Washington state. The plan was to create a 5-reactor complex that would generate a significant portion of the region's electric power and usher in a new era of nuclear energy. It was anticipated to bring economic prosperity, job opportunities, and independence from fossil fuels. However, this grand project was eventually abandoned in 1983, an outcome that was precipitated by a myriad of factors. Financial difficulties arose due to cost overruns, delays in construction, and a sharp decrease in projected electrical demand. The initial estimated cost of the project was overshadowed by ballooning expenses as the project faced problems with both design and implementation. Public opposition also played a significant role in the project's downfall. The 3 Mile Island accident in 1979 heightened fears about nuclear power safety, leading to vigorous protests and legal challenges aimed at halting the Satsop project. This, along with mounting skepticism about the project's viability, culminated in its premature end. Today, the 2 colossal cooling towers stand as silent reminders of a bygone era, a testament to an ambitious project that collapsed under the weight of its own ambition and the mounting pressures of the time. Pledged to boost the country's energy generation, the gas-fired power plant in Thailand, reminiscent of the notorious Satsop nuclear power plant, came under fire due to environmental concerns. Situated in the heart of the Map Ta Phut industrial estate in Thailand, a project initially heralded as a breakthrough in sustainable energy production, the plant was intended to use sophisticated gas-fired technologies, setting it apart from conventional power plants. The initial goals of the Map Ta Phut project were ambitious, aiming to drastically increase Thailand's energy production, reduce dependency on foreign energy, and create a model for future sustainable energy projects. Incorporating cutting-edge technologies such as combined-cycle gas turbine systems, the plant promised efficient power production with reduced carbon emissions. However, the optimism soon faded, as the plant's emissions were linked to afflictions in the local population, casting a dark shadow over the project's initial vision. The particular substances released by the plant, including harmful particulates and volatile organic compounds, posed significant health risks to the surrounding communities. This raised grave environmental and safety concerns, leading to heightened scrutiny by environmental agencies and activists. These environmental grievances eventually culminated in the plant's shutdown. The closure of the plant, once celebrated as a symbol of Thailand's progressive energy future, served as a stark reminder of the delicate balance between industrial growth and environmental sustainability. The Gres 2 power station, nestled in the heartland of Kazakhstan, stands as a monumental vestige of the Soviet Union's industrial prowess. This coal-fired behemoth was more than a power plant. It was an embodiment of the Soviet Union's technological dominance and a symbol of its relentless march towards progress. With its towering chimney, which remains one of the highest artificial structures in the world, the Gres 2 power station was an awe-inspiring sight that once lit the homes of millions. Sadly though, like all things, the power plant's years of glory were not to last indefinitely. It began to show signs of functional decay due to a range of issues. Firstly, its operational efficiency began to dwindle over time, partly due to outdated technology, and partly due to the wear and tear of its infrastructure. Then, environmental concerns began to take center with the station's coal-fired operations, contributing significantly to air pollution and carbon emissions. Moreover, the rise of renewable energy alternatives contributed to its decline. This shift in the energy landscape, with a growing emphasis on sustainability and green energy, further diminished the relevance of the Gres 2 power station, which was firmly rooted in the old paradigm of fossil fuel reliance. The station's cessation had notable ripple effects on the surrounding community and the broader energy industry. Locally, it led to job losses and economic decline, as many residents were directly or indirectly dependent on the plant for their livelihoods. On the industrial level, the closure of the GRS-2 power station signaled the end of an era, underscoring the urgent need for modernization and adaptation to new, cleaner sources of energy. In the United States, the Altamont Pass wind farm, one of the pioneering ventures in wind energy, first emerged in the late 20th century. The project was a beacon of innovation, exemplifying the country's mission towards renewable energy. Despite the widespread enthusiasm for this alternative energy source, local communities were initially divided on the project's impact. Over time, this division turned into unified concern as the consequence of the wind farm on local bird populations came to light. The turbines, though small and fast-spinning, posed an unforeseen threat to the birds, causing a significant rise in fatalities. The discovery of this ecological impact led to an urgent reassessment of the wind farm's operation. The subsequent course of action was the decommissioning of the Altamont Pass wind farm, marking a vital turning point in our understanding of balancing technological progress with nature's preservation. The Shoreham nuclear power plant, located in the United States, was a monumental project that held great promise but eventually fell short due to a variety of challenges. From its inception, the Shoreham plant was a complex endeavor. The planning phase involved several years of intricate work, utilizing advanced technologies of the time, and aimed to provide a new and efficient source of energy for the region. Moving on to the construction, it was no less than an engineering marvel, employing thousands of laborers and technicians, and spending millions in the process. The plant was indeed a sight to behold once it was fully constructed. However, despite the meticulous planning and arduous construction, the Shoreham nuclear power plant never became operational. The overriding factor was public opposition. The local residents, environmental activists, and numerous other stakeholders voiced their concerns about the potential hazards of nuclear energy. This was a time when the memory of the 3 Mile Island accident was still fresh in public consciousness, and the fear of a similar incident happening at Shoreham was palpable. The challenge of creating an effective evacuation plan was a major hurdle that the authorities struggled with. The plant was located on Long Island, a highly populous area, and critics argued that it would be nearly impossible to evacuate everyone quickly and safely in the event of a nuclear incident. Ineffectual strategies and planning compounded these concerns, and despite the completed state of the plant, it was eventually decommissioned without ever being put into operation. The Yerevan Thermal Power Plant, a gas-fired station located in the heart of Armenia, was a project of great ambition and promise. At its inception, the goal was to provide the nation with a reliable and consistent source of power, using the latest in gas-fired technology. This advanced technology boasted high performance rates, combining both high-pressure steam and gas turbines. However, over time, the promise turned into a challenge. The plant was ultimately shut down due to a combination of high pollution levels and inefficiency. Unfortunately, the technology used, while innovative, failed to keep up with the demands for cleaner, more sustainable energy solutions. The closure of the Yerevan thermal power plant underscored the environmental impact and the inescapable reality of fossil fuel-based energy generation. Previously serving as a significant hydroelectric energy source, the Elwha River dams in Washington, USA, posed a significant ecological risk to the river's intricate ecosystem. They presented a formidable obstacle to fish migration routes and induced alterations to the river's spontaneous flow. The decision to dismantle these power stations wasn't taken lightly. It was a conclusion reached after contentious debates and careful consideration of the ecological impacts versus the energy production capabilities of the dams. The primary reasons underpinning this decision were the decline in fish populations, the alteration of the river's natural course, and the wider implications for the delicate balance of the river's ecosystem. Once the decision was made, the process of dismantling began. This ambitious initiative, often considered one of the most significant dam removal projects in the history of the United States, required extensive planning and meticulous execution. The dams were taken apart, piece by piece, in a systematic way to prevent any sudden disruptions to the river's flow or additional harm to the ecosystem. The impact of this project on the river's ecosystem has been profound. Not only did it restore the river's natural flow, but it also led to a rejuvenation of fish populations, and the surrounding forest ecosystem experienced a remarkable recovery. This recovery process, however, was not without its own set of challenges, particularly in balancing energy production and environmental preservation. The removal of the dams represented a substantial loss in hydroelectric power, which then needed to be compensated for with alternative energy sources. This underscored the crucial challenge of striking a balance between the needs of society for energy production and the imperative to preserve and protect our environment. The Elwha River Dam project, thus, serves as a pivotal case study in environmental restoration and the complex dynamics of sustainable energy production. Once the world's largest tidal power station, the Rance Tidal Power Station was a marvel of engineering. Nestled in Brittany, France, this colossal feat of human ingenuity harnessed the raw power of the ocean tides to illuminate homes and power industries. The station was more than just a power source. It was a testament to the innovative spirit of the time. However, beneath this fascinating exterior lurked a series of challenges. The station's groundbreaking design did not come cheap. Building a power station in the sea presented a slew of hurdles. From dealing with the unpredictable ocean tides to the complex logistics of offshore construction, the initial costs soared high above the anticipated budget. And the costs didn't stop piling up after the construction was completed. The harsh marine environment was relentless, causing a rapid wear and tear on the station's equipment. This translated into significant maintenance costs, further straining the economic feasibility of the project. These incessant financial burdens eventually led to the closure of the power station, casting a harsh light on the economic challenges of tidal energy. No matter how promising or innovative a project may appear, it must also be economically viable to be sustainable in the long run. Despite its initial promise and grandeur, the Rance Tidal Power Station was ultimately closed due to its high construction and maintenance costs. This serves as a sobering reminder and a cautionary tale for all future endeavors in the pursuit of tidal energy. The Bataan Nuclear Power Plant is a poignant symbol of a large-scale project that was fully constructed but never operated in the heart of the Philippines. Built between 1976 and 1984, during the era of President Ferdinand Marcos, the plant utilized the latest generation of light-water nuclear technology, which was expected to bring a revolution in the country's energy sector. Constructed at a cost of over $2.2 billion, this colossal structure was planned to have a capacity of 621 megawatts, which would have made it one of the most significant power plants in the country. To this day, it remains the only nuclear power plant in the nation, a veritable titan of engineering that could have dramatically altered the energy landscape of the Philippines. However, the plant was deemed too risky and was never fueled. It was categorized as highly hazardous due to its precarious location. The plant was alarmingly close to the Mount Pinatubo volcano, which erupted magnificently in 1991, just a few years after the plant's construction. Moreover, it was also found to be too near to a major geological fault line, the Manila Trench, which increased the risk of an earthquake. The intersection of these natural threats essentially sealed the fate of the Bataan nuclear power plant, rendering it a dormant giant in the energy field. Nestled within the immense boundaries of California's Mojave Desert, you'll find the now dormant Solar One power station. This power station, once a pioneering solar thermal plant in the United States, stands as a mute testament to a past epoch of dwindling efficiency and rising costs. The brainchild of visionary scientists and engineers, the Solar One power station was born out of a desire to harness the sun's vast energy in the early 1980s. This was a time when renewable energy was still in its infancy, and the station represented the bleeding edge of technology, with its innovative use of heliostats to focus sunlight onto a central receiver on a tower. This concentrated solar power technology was groundbreaking in those days. However, like any ambitious project, the Solar One power station faced its fair share of challenges during its operational years. The biggest among them was the inherent inefficiency of its thermal storage system. Despite utilizing more than 1,800 mirrors to reflect sunlight, the plant struggled to maintain a steady power supply during periods of cloud cover or at night, leading to inconsistent power generation. Another challenge the plant grappled with was the escalating costs. The operation and maintenance costs of the plant, coupled with the high initial investment, drove up the cost of energy production significantly. These operational difficulties and financial pressures eventually led to the decommissioning of the Solar One power station. While the plant may stand silent today, it's a potent reminder of the strides we've made in the renewable energy sector and the lessons learned along the way. Exploring these defunct power stations provides us with crucial knowledge about the intricacies of energy generation. Each mishap imparts a lesson, stressing on the need for sustainable, renewable energy sources, such as solar power. Harnessing the sun's energy is a promising prospect in our quest for a more sustainable future, thanks to its abundance, cleanliness, complete renewability. As we wrap up our worldwide tour, bear in mind that these unsuccessful power stations stand as symbols of the hurdles we need to surpass for an energy-efficient future. We appreciate your company through this enlightening journey. If this video piqued your interest, feel free to share it and subscribe to Ecolution for more informative content. Our collective effort can indeed make a difference.